Okay, good afternoon. I remain my name, Mr. Kazim Olajuwaju. Good day. So, today, last time I talked about dimensional analysis, but today we are going to use the application. We want to prove equation of motion whether it's dimensionally correct or not correct. In some cases, just like some WAEC, like 3 or 4 years ago, they asked some students that whether equation of motion or any other equation, how do we know whether it is dimensionally correct? Number one, the right equation must be equal to the what? The left equation dimensionally. Both equations must be what? The same, using dimension analysis. So last time I talked about the three basic dimensional analysis, which is mass, which is represented as n, length is represented as what? L, and time is t. Now let me look at this one. If this one, whatever you get here and here is not the same, meaning that it is not dimensionally correct. But if whatever you get here is equal to this is definitely it is dimensionally correct. So let's start from there. The velocity is equal to what? The first one, which is I. Velocity is equal to distance, which is displacement over time. Now, as you can see D, which is length. Length is denoted by L, and T, which is the time, is denoted by what? T. So, meaning that the dimension of velocity is equal to LT minus 1. Let's look at this. So, let's try the other side. The U is equal to U also initial velocity. This is final velocity, and U is initial velocity, which means it's the same thing. We have displacement over time, meaning that L is equal to T. Then we have LT minus 1. This one and this one is the same. So finally we have acceleration times time. AT equal to, then what is acceleration? Acceleration is equal to velocity over time, then multiplied by time. As you can see, this and this cancel, which we have V is equal to G, displacement over time as well. So we have L all over T, which is equal to LT minus 1. So this one is correct, this one is correct. We have the same thing in the parameter. This is equal to this is equal to this, showing that the first equation is what? The equation of motion, really the first equation of motion is dimensionally correct. Let's try the second one. The second one is this. So it's what? S. S is distance, which is L. We all know S is distance. We don't need to drag that one. Then we have UT. Then UT equal to, what is the U? U is equal to displacement, as you know, over time. Then times what? Times T. Automatically, this T cancel this T. We remain with D. And what is D? D is L. So L, which we have the same thing here, we have the same thing here. So let's look at this one finally. So we have half AT squared. Now, in dimensional analysis, take note of this. We are not applying the constant. Any constant, whether you have 2, 3, 4, 5 like that, anything number, we are not applying. So, meaning that 2 is not going to be applicable. We only apply AT squared. So we apply this one. What is velocity? Velocity is equal to acceleration is equal to distance over time, then times T squared. The acceleration is so. Meaning that we have T cancel T, we have V, then V times T. Then what is V? What is our displacement? V is velocity, which is equal to displacement over time times this is time. So this one cancel this one, so we have D. And what is our D? Which is the length, which is N. As you can see, this one is equal to this, and this one is also equal to, which means that this equation is dimensionally correct. Now, what you are going to do now, I'm not going to be the one to solve the last one for you. This is take home for you to try it as a practice at home. The last equation, which is V squared equal to U squared plus 2AS. So it is now left for you to prove this particular equation, whether it is dimensionally correct or it's not dimensionally correct. So I need your answer in the comment section. So prove this one. If it's dimensionally correct, let me know and put it. So for more inquiry about home tutor or online tutor, meet me back on this particular page.